Hi, this is called Binomial Experiments because we're going to talk about binomial experiments. So you can see in your notes these are the features of a binomial trial, and I'm expecting you to read these on your own. In addition, if you look at your reading assignments on Canvas, the chapter 4 notes on random variables, if you take a look at that reading assignment, this is the beginning material on random variables, which we talked about before spring break. And here's information about the binomial probability density function. So what's a binomial experiment? It's an experiment that's performed a fixed number of times where the trials are independent. Each trial has two possible outcomes, success or failure, and the probability of success at every trial is exactly the same. So this, in this particular video, I'm just going to talk about what constitutes a binomial experiment and what doesn't. But as you know, you are supposed to be reading these notes so that you can better understand the binomial formula and you know what it means to be a binomial random variable. So we will continue here. Which of the following, can be considered a binomial experiment? So let's take a look, and we're going to go through sort of the checklist that we have for what constitutes a binomial experiment. So we're going to see if if the experiment constitutes independent, fixed number of trials. They could be classified as success or failure, and if the probabilities are the same from trial to trial. So let's look at A. Surveying 100 people to determine if they like sudsy soap. Okay, it's a fixed number of trials. The trials would be independent because from person to person, they're not, related or connected. So one person's opinion is not going to affect another person's opinion. And presumably, there are a fixed number of trials. It's 100 people. Success is like, failure is not like, and probabilities are the same from trial to trial. So this would be then a yes. Oh, darn it. This is what I want. That's a yes. Tossing a coin 100 times to see how many heads occurred. Okay, so what's the random variable counting? The random variable is counting the number of heads. So that's the random variable. Is this independent? Are these independent trials? Well, if you're tossing a coin, the trials are independent from one to the next. The probability of success is the same on each trial because you're using the same coin. This can be separated into a success-failure experiment. And again, it's a fixed number of trials because we're tossing the coin 100 times. So this would also be, yes, result in a binomial experiment. Drawing a card with replacement from a deck and getting a heart. Well, you're replacing the card back in the deck. So these would be independent trials. Success would constitute getting a heart. So, that's going to be a yes or a no. Fixed number of trials. It doesn't say. How many times are we performing this experiment? That's unknown here. So if it's just a single time drawing a card, like a single time drawing a card from a deck and getting a heart, if we're just performing this on one single time, but it says with replacement. So it sounds like we don't have a fixed number of trials here. So if we don't have a fixed number of trials for this experiment, then we wouldn't have a binomial experiment. If we did this just an ad hoc number of times without a number of trials specified, then I would have to say no. Okay, asking 1,000 people which brand of cigarettes they smoke. Is this a success-failure experiment? I don't think so. I mean, I get the fixed number of trials because that's the 1,000 people. And independence, yes, because they're not the same. They wouldn't be related. So, there's no connection from trial to trial. They would be independent. But where's the success failure here? So which brand of cigarettes? This is not a success-failure situation, so this is going to be a no. Testing 4 brands of aspirin to see which brands are effective. Again, let's think. Which brands are effective? Okay, so can we say success or failure is effective or not effective? 4 brands, each brand constitutes a trial of the experiment. I'm starting to like this. Oh, but independence. Well, I mean, these are different brands. I mean, you know, the probability not necessarily the same from trial to trial because we're different brands. So we don't have independence, and we don't have the probabilities the same necessarily from one trial to the next. So I'm going to go with no on this one. Testing 1 brand of aspirin by using 10 people to determine whether it's effective. Oh, that's my phone. Whoopsies. So, yeah, it's effective or not, so that's success or failure. 10 people, so there's going to be independent, and it's also a fixed number of trials, and it's the same aspirin, so the probabilities would be the same from trial to trial, so this is going to be a yes. Asking 100 people if they smoke. So independence, yes. Is that success failure? Yes, either they smoke or they don't. Fixed number of trials, yep, that's 100 people. Probability the same from person to person? I would assume so, so we're going to go with yes here. My daughter keeps calling me. Checking 1,000 applicants to see if they were admitted to White Oak College. Okay, independent? Yes, indeed, 1,000 different applicants. Success, failure, yep, they either were admitted or not. Fixed number of trials, we have 1,000 applicants. Probability the same from trial to trial. Let's go with everybody has equal possibility of getting in, so this would also be then a yes. Surveying 300 prisoners to see how many different crimes they were convicted of. Is that a success, failure? Does each prisoner constitute a success or failure trial? No. Each prisoner, the question is how many crimes. So this is not repeated applications of a success or failure, you know, 2 outcome type of experiment. So this is going to be a no. Surveying 300 prisoners to see whether this is their first offense. Well, it will either be their first offense or not, so it can be success or failure. Independent, because they're different prisoners. Fixed number of trials, yes, each prisoner constitutes a trial of the experiment, and we'll assume the probabilities are the same from prisoner to prisoner, that this is their first attempt or offense, so this would be a yes. Okay, next time we'll talk about calculating binomial probabilities.